This is problem number 3 on the sample test problems for test number 2. The table below gives values for two differentiable functions f and g and for their derivatives. Find each of the following. A, h prime of 2 if h of x equals f of x times g of x. So what we need to do is think about, before we look at the table, we need to figure out what the derivative rule is for f of x times g of x. That's a product rule. So we're going to find h prime of x, not h prime of 2, first h prime of x, using the product rule. First times derivative of the second plus the second times derivative of the first. Now that we've got that, we can then replace all of these x's with 2's because we wanted h prime of 2. And now I think all we need to do is find these four numbers in the table. So f of 2, let's see, f of 2 looks like it's right here. That's a 0. G prime of 2, that's way down here. That's a 1. So it looks like we have a 0 times 1 plus, then we need g of 2. So g of 2 is 3. And then f prime of 2 is negative 1. So 3 times negative 1. Altogether, it's negative 3, and that's our answer to this question. Part B, find j prime of 3 if j of x is equal to f of x over g of x. Okay, this is pretty similar to the previous one, except now it's a quotient rule. So before we find j prime of 3, we need j prime of x. So it's a quotient rule. I always put the bottom squared first because otherwise I'll forget it. So the bottom thing gets squared. So we do bottom times derivative of the top. Minus, in the quotient rule, top times derivative of the bottom. And again, over the bottom squared. So now all of those x's become 3's in this case. So we get j prime of 3. And now that we've got that, again, we just need to grab all of these numbers from the table. So let's see how many we can grab here. G of 3, let's see, that's over here, that's 4, times f prime of 3, that's 2, minus f of 3, that's a 1, times g prime of 3, that's 2, and that's all divided by g of 3 squared. So we've got 4 times 2 minus 2 times 1. And then g of 3, is that 4? Let's make sure we get that right. G of 3 is 4. Okay, so we've got 8 minus 2 over 16, 6 over 16, or 3/8. And then we'll move on to part C. K prime of negative 1 if k of x equals f of g of x. All right, this is not a product or a quotient. This is a composition, which means chain rule. Okay, so we need to know the derivative rule, the chain rule in terms of functions when it's written like this. K prime of x before k prime of negative 1 equals the outer function derivative evaluated at the inner function times derivative of the stuff, derivative of the inside. So that's the chain rule in formula version. And then again, all of the x's become, in this case, negative 1. Okay, so we're looking here for g of -1 and g prime of -1. F doesn't come into it just yet. So g of -1 is here, and g prime of -1 is here. So 1 and 2. So this is really f prime of 1 times 2. I'm just going to separate this off. And then the only thing left to do is grab f prime of 1. And f prime of 1, I'll highlight this in blue as well. F prime of 1 is right there, -1.5. So this is -1.5 times 2. -3 is our final answer. Again, I'll draw something in here just to make sure we don't get the problems mixed up. Next one, p prime of 0 if p of x is equal to g of f of x. Same idea, still chain rule. P prime of x equals, it's the derivative of the outer, times derivative of the inner. G prime of f of x times f prime of x. We'll replace all of those x's with zeros. So what we need is f of 0 and f prime of 0. So we'll circle these in purple. F of 0 is 3. F prime of 0 is -3. So this is g prime of 3 times -3. And so the last thing we need here is g prime of 3. That's in the table. G prime of 3 is way over here. No, it's not. G prime of 3 is way over here, and it's 2. So this is really 2 times the -3 that was waiting around. -6 is our answer. Okay, last one, part E. Q prime of 1 if Q of x equals G inverse of x. You can assume that G is invertible. Okay, first we need our formula for the, excuse me, for the derivative of an inverse function. So our fancy formula is 1 over the derivative of the inverse of x. So that's our general formula to find the derivative of an inverse function. 1 over derivative of inverse of x. And now we're ready to replace all those x's with the number. Q prime of 1 is equal to 1 over g prime of g inverse of 1. Okay, 1 over g prime of, so now we need g inverse of 1. G inverse of 1, let's see, that means that 1 was an output, which means 1 was the y value, and we want the x value. What x value gives you 1 as the output of the g function? So we're going to look up here in the g row. We're looking for the output to be 1, that's a y value, and then the question is what input did it come from? So miraculously, the number 1 happens to be in this list. If it wasn't, then we couldn't answer this question. So the y value was 1. Where did it come from? It came from an x value of -1. So all that is to say, g inverse of 1 turned out to be -1 from the table. So when we have over here, g inverse of 1, it's actually -1. And then we're doing 1 over, and then we just need to grab g prime of -1. So g prime of -1 is this number down here. So g prime of -1 is 2. So this is a 1 over 2, or a half.